The air above the Judean hills trembled with a terrifying sound that was neither thunder nor the roar of a beast, but the mechanical scream of twisted sinew releasing its deadly burden. Inside the besieged walls of Jerusalem, the defenders looked skyward with dread as a massive stone blocked out the sun. This was the year 70 AD, and the Roman legions had arrived with their engines of war. The ground shook as the projectile slammed into the limestone fortifications, shattering masonry and morale in a single violent instant. Dust billowed into the hot afternoon air, choking the screams of the terrified inhabitants, who realized that their stone walls were no longer a guarantee of safety against the might of Rome. Legionaries stood in disciplined formation miles from home, watching the destruction with a grim satisfaction born of rigorous training and absolute obedience to their commanders. The siege engines were not merely weapons of war to them, but symbols of Roman order imposed upon a chaotic world. Each impact represented the inevitable advance of the empire and the futility of resistance against the Senate and people of Rome. The dust settling on their armor was the dust of a city that had dared to defy the greatest power the Mediterranean world had ever known. They waited for the signal to advance, knowing that the machines would do the heavy work before the swords were drawn. General Titus Flavius Vespasianus watched from a high vantage point, surrounded by his staff officers and engineers who calculated trajectories with mathematical precision. He knew that time was the enemy of any besieging army, as disease and hunger could decimate his ranks faster than any enemy arrow. The bombardment had to be relentless, and the psychological terror absolute to force a surrender or create a breach. He observed the rhythmic motion of the artillery crews, working like parts of a great clock. They wound the torsion springs and loaded the heavy stones with a cadence that spoke of endless drilling. This was industrial warfare in the ancient world. For days and nights the barrage continued without ceasing, turning the once proud battlements into unstable piles of rubble. The defenders inside the city tried to sleep, but the whistling of bolts and the crashing of rocks kept them in a state of perpetual terror. They reinforced the walls with timber and earth, but the Roman machines simply adjusted their aim and chipped away at the new defenses. It was a battle of endurance between the stubborn will of the rebels and the cold mechanical genius of the Roman military machine. The air was thick with the smell of burning pitch and the dust of pulverized stone. The sheer variety of projectiles raining down on the city demonstrated the versatility of Roman engineering. Immense stones crushed the battlements, while heavy bolts from scorpions pierced through shields and armor, pinning men to the ground. Incendiary pots filled with burning mixture set rooftops ablaze, creating chaos in the streets behind the walls. The Romans were not just attacking the physical structure of the city, but were dismantling the society within it piece by piece. Every crash and every fire was a message that the protection of the old world was failing. The siege engines were the harbingers of a new and ruthless reality. The stakes of this conflict extended far beyond the immediate fate of Jerusalem or the survival of its inhabitants. The reputation of the Roman Empire itself was being tested on these dusty hills. If a rebellious province could withstand the full might of the legions and their technology, then the illusion of Roman invincibility would shatter. Revolts would spring up from Gaul to Syria, and the Pax Romana would dissolve into blood and anarchy. The engines of destruction were therefore essential tools of statecraft, designed to prove that no wall was high enough and no gate strong enough to keep out the imperial will. On the other side of the walls, the defenders fought for their spiritual and physical survival, believing that divine intervention would save them from the iron grip of the invaders. They were outmatched in numbers and technology, but their desperation gave them a ferocious courage. They watched the giant machines with a mixture of awe and hatred, calling them monsters of wood and iron. Every time a stone missed its mark or a machine malfunctioned, a cheer went up from the ramparts. However, hope was a finite resource that depleted with every section of wall that crumbled into the valley below. The gap between the combatants was defined by engineering prowess and the ability to mobilize resources on an industrial scale. The Romans brought with them a tradition of mechanics and mathematics inherited from the Greeks, but perfected with Roman pragmatism. They did not just build weapons, they built systems of logistics that allowed them to transport massive timbers and miles of rope across hostile terrain. The rebels had passion and knowledge of the terrain, but they lacked the capacity to manufacture the counter-siege equipment needed to silence the Roman batteries. It was an asymmetrical war of attrition. Building these engines required a staggering amount of specific materials that had to be sourced from across the empire. The wood had to be seasoned oak or ash strong enough to withstand immense tension without snapping under the strain. The iron for the fittings had to be forged by master smiths who understood the stresses involved in torsion mechanics. Most importantly, the springs were made from animal sinew or human hair, which provided the best elasticity and durability. Thousands of cattle were slaughtered not just for food, but to harvest the tendons required to power the catapults and ballistae. This was the Roman way of war, where victory was engineered long before the first soldiers set foot on the battlefield. It was a triumph of organization over individual heroism and calculation over chance. The legions were a machine, and the catapults were merely an extension of that machine, designed to process the enemy into submission. The soldiers operating them were technicians as much as warriors skilled in the maintenance and repair of complex devices. They carried spare parts and tools alongside their swords and shields, ready to fix a jammed winch or a frayed rope under fire. At the heart of this technological marvel stood the Praefectus Fabrum, or the chief engineer responsible for the design and operation of the artillery. He was a man of science in an age of superstition, relying on geometry and physics to bring down kingdoms. He carried the legacy of Vitruvius and Archimedes, applying their theoretical knowledge to the bloody business of siege warfare. His mind was filled with angles and tension ratios, constantly calculating the distance to the target and the weight of the projectile. To the soldiers, he was a wizard, but to the enemy, he was the architect of their doom. The chief engineer walked the line of machines, inspecting the tension of the ropes and the condition of the frames. He listened to the creak of the wood and the hum of the wind through the torsion springs, tuning the instruments of death like a musician. A snapped cable could decapitate a crew member or send the projectile flying back into their own ranks, so his vigilance was the difference between life and death. He barked orders to tighten a winch here or replace a bolt, there ensuring that every machine was operating at peak efficiency. The design of these weapons was based on the principle of torsion, where energy was stored in twisted bundles of fibers. When the lever arm was pulled back, it twisted the ropes tighter, storing immense potential energy. Upon release, the ropes untwisted with violent speed, snapping the arm forward and launching the projectile. This was far more efficient than the simple tension of a bow, allowing for greater range and hitting power. The Romans had standardized these designs, creating a uniform artillery corps that could be deployed anywhere in the known world. Mathematics played a crucial role in the calibration of these engines, as the engineer had to understand the relationship between the diameter of the spring and the weight of the stone. A formula derived from earlier Greek experiments dictated that the optimal spring diameter was 1/10 of the cube root of the projectile weight. This level of sophistication allowed the Romans to scale their weapons up or down depending on the tactical requirements. They could build massive stone throwers for breaking walls or smaller rapid-fire bolt shooters for clearing ramparts. The raw materials for the torsion springs were a constant concern for the logistical officers of the legion. Women in besieged cities sometimes cut off their own hair to make ropes for the defenders, but the Romans had a steady supply of sinew from their baggage trains. The fibers had to be kept dry and oiled to prevent rot and loss of elasticity in the damp or rain. A wet spring was a useless spring, so the machines were covered with heavy leather tarps when not in use. The maintenance of the artillery was a never-ending task. The ballista was the sniper rifle of the ancient world, designed to shoot heavy bolts with pinpoint accuracy over long distances. It consisted of 2 vertical torsion springs that powered 2 arms connected by a bowstring. When the string was drawn back by a winch, a bolt was placed in the groove of the slider. The operator could aim the weapon using a universal joint that allowed for vertical and horizontal adjustment. A skilled crew could hit a single man on a wall from 300 yards away, striking fear into enemy commanders. The Scorpion was a smaller version of the ballista, highly mobile and deadly against infantry formations. It fired smaller iron-tipped bolts that could punch through shields and armor like paper. These machines were often deployed in batteries on the flanks of the Legion to break up enemy charges or suppress archers on the walls. The rapid rate of fire and the terrifying sound of the bolts whistling through the air made them a psychological weapon as well as a physical one. A single legion could field dozens of these machines, creating a wall of flying death. The onager, or wild ass, was the heavy artillery of the Roman army, designed to smash fortifications and buildings. Unlike the two-armed ballista, the onager had a single throwing arm powered by a massive horizontal torsion bundle. When released, the arm swung up and hit a padded stop, launching a stone from a sling attached to its tip. The kick of the machine when it fired was so violent that it resembled a bucking donkey, giving the weapon its animalistic name. It was inaccurate but devastatingly powerful. The physics of the torsion bundle allowed the onager to throw stones weighing over 100 pounds for hundreds of yards. The kinetic energy delivered by such a projectile was enough to shatter solid masonry and bring down towers. The stones themselves were often roughly hewn spheres of limestone or granite quarried on site by the legionaries. Sometimes the Romans would launch baskets of snakes or rotting carcasses to spread disease and panic among the enemy. The onager was a blunt instrument of terror. Loading the onager was a labor-intensive process that required the strength of several men working a large winch. The throwing arm had to be ratcheted down against the immense resistance of the twisted ropes. A trigger mechanism held the arm in place until the command to fire was given. The crew had to stand clear of the swinging arm, which could easily kill a man if he was in the wrong place. The sheer physical force contained within the twisted fibers was a constant danger to the operators. The trigger mechanism was a marvel of simple engineering, usually consisting of a metal hook or pin that could be released with a sharp blow from a mallet. Once the pin was knocked out, the stored energy was released in a fraction of a second. The sound was deafening, a sharp crack, followed by the deep thud of the arm hitting the stop. The stone would arc high into the air, tracing a parabola of destruction before descending on the hapless target. Watching the flight of the stone was a moment of suspended animation for both the shooter and the target. Calibration and aiming required a mix of experience and intuition, as there were no optical sights or computer guidance systems. The engineer would observe the fall of the shot and order adjustments to the tension of the springs or the elevation of the machine. They used wedges to raise or lower the front of the frame and large levers to traverse it left or right. A good crew could walk their shots onto a target within a few rounds, systematically destroying a section of wall. The psychological impact of the bombardment was often as effective as the physical damage. The constant whistling and crashing wore down the nerves of the defenders, depriving them of sleep and hope. The Romans knew this and would often maintain a slow, steady rate of fire throughout the night to ensure there was no rest for the wicked. The randomness of the death raining from the sky meant that nowhere inside the city was safe. It created a sense of helplessness that eroded the will to fight. To make the stones harder to see against the sky or the ground, the Romans would sometimes blacken them with soot or paint. This made it difficult for the defenders to spot the incoming projectile and dodge out of the way. A stone that you could not see was a stone that you could not prepare for, adding another layer of terror to the siege. The defenders would post lookouts to watch for the flash of the firing arm, but often the warning came too late. Mobility was a key advantage of the Roman military machine, and the artillery was designed to move with the army. The caraballista was a cart-mounted ballista that could be deployed quickly in open battle or during a siege. Mules or horses pulled these carts, allowing the legion to bring heavy firepower to bear wherever it was needed. This tactical flexibility meant that the Romans were never without their artillery support, even in the most rugged terrain. Siege towers and battering rams worked in unison with the artillery to overwhelm the defenses. While the catapults and ballistae suppressed the defenders on the walls, the towers would roll forward to deliver boarding parties. The rams would pound against the gates or the base of the walls, protected by covered sheds. The artillery provided the covering fire that made these other operations possible, keeping the heads of the enemy down, while the heavy equipment moved into position. The defenders were not without their own countermeasures and ingenuity in the face of this onslaught. They hung sacks of chaff or wool over the walls to cushion the impact of the stones and absorb the energy. They built secondary walls behind the threatened sections, hoping to trap the Romans if they broke through. They even sortied out at night to burn the machines and kill the crews in desperate raids. But the Romans were relentless, rebuilding whatever was destroyed and continuing the bombardment. As the siege dragged on, the intensity of the conflict escalated into a brutal struggle for survival. The Romans built circumvallation walls to starve out the city and prevent escape. The artillery fire became more concentrated, focusing on weak points identified by the engineers. The dust from the crumbling walls coated everything in a fine white powder, giving the soldiers a ghostly appearance. The roar of the onagers became the heartbeat of the siege, a constant reminder of the passing time. Night bombardment was particularly terrifying, as the flaming pots traced arcs of fire across the dark sky. The fires illuminated the city, revealing the devastation and the desperate figures of the defenders. The shadows danced on the ruined walls, creating monstrous shapes that played on the fears of the superstitious. For the Romans, the night was just another shift in the factory of war, a time to continue the work of reduction. The logistical train required to sustain this effort was immense, stretching back to the coast and the supply ships. Convoys of wagons brought food for the men and fodder for the animals, as well as the endless supply of bolts and stones. The engineers had to ensure that the machines were kept in repair, replacing worn parts and fraying ropes. It was a massive industrial undertaking that showcased the organizational genius of the Roman state. The question that hung over the battlefield was whether the ancient walls could withstand the relentless pounding of the new technology. The fortifications of Jerusalem were legendary, built of massive stones that had stood for centuries. But the Romans had brought physics and geometry to a stone fight. The defenders prayed to their god, while the Romans trusted in their torsion springs. It was a clash between faith and engineering. The moment of the breach finally arrived with a thunderous crash that echoed through the valley. A section of the outer wall, weakened by days of impact, collapsed into a heap of rubble and dust. The shout went up from the Roman lines, a roar of triumph that drowned out the cries of the defenders. The barrier that had separated the legions from their prize was gone, leaving a gaping wound in the city's defenses. The infantry rushed forward, their shields locked in a testudo formation to protect against the hail of arrows and stones from the remaining defenders. They climbed over the debris of the wall, their hobnailed sandals finding purchase on the broken stones. The artillery shifted its fire to the inner defenses, creating a rolling barrage ahead of the advancing troops. The discipline of the legionaries held firm as they poured into the breach. Street fighting ensued, a chaotic and bloody affair, where the long-range advantage of the artillery was lost. But the machines had done their job, opening the door for the heavy infantry to finish the work. The legionaries fought with gladius and shield, clearing the houses and alleys with ruthless efficiency. The defenders fought with the fury of the doomed, but they were pushed back step by bloody step. The fall of the temple was the culmination of the siege, a symbolic and literal destruction of the rebellion. The fires that consumed the structure were started during the fighting, adding to the inferno that engulfed the city. The great stones of the Temple Mount were toppled by the soldiers, fulfilling the prophecy that not one stone would be left upon another. The smoke rose high into the sky, a funeral pyre for a nation. The reveal was a landscape of utter devastation, where a vibrant city had once stood. The walls were breached, the buildings were burned, and the population was enslaved or dead. The Roman machines sat silent on the hills, their work complete. They were the silent witnesses to the power of the empire and the cost of defiance. The victory was absolute, and the message was clear to all who would challenge Rome. The aftermath saw the Roman engineers dismantling their machines and packing them away for the next campaign. The valuable metal fittings and the precious sinew springs were carefully stored. The stones that had not been fired were left scattered on the ground, monuments to the siege. The legionaries marched away, leaving behind a ruin that would serve as a warning for generations. The technology of the catapult and ballista spread across the empire, becoming the standard for siege warfare for centuries. Every legion carried the knowledge of their construction and operation, ensuring that Roman power could be projected anywhere. The designs were refined and improved, but the basic principles of torsion remained the same. It was a technology that shaped the borders of the ancient world. Evolution of these machines continued into late antiquity, eventually giving way to the counterweight trebuchet in the Middle Ages. But for hundreds of years, the torsion engines of Rome were the apex of military engineering. They represented the marriage of science and wore a legacy that continues to the modern day. The intellectual descendants of the Roman engineers still design the weapons of the future. In the end, the Roman catapult and ballista were more than just weapons. They were symbols of a civilization that prioritized order and control. They were the physical manifestation of the Roman mind, disciplined, precise, and ruthlessly effective. The dust has long since settled over the ruins of Jerusalem and Carthage, but the echo of the torsion springs still resonates in the history of warfare. The whisper of time carries the sound of the engineer's winch, tightening the sinew of destiny.